Hi class, this is course 3, lesson 81, central angles and arcs. So we have a circle here, and remember that the total number of degrees in a circle is 360 degrees. And so if you have a center and you have a diameter, you know that each side is 180 degrees because we divided this circle in half. But if I drew another one and I said, well, this is 50 degrees, you should be able to tell me the other measures of these central angles. Remember, a central angle has its vertex at the center of the circle. Okay? But also, so this central angle is 50 degrees. Now remember that we had 180 degrees here, so this angle is 180 minus 50, which would be 130 degrees. I also know it's obtuse, so that makes some sense. Now, these are vertical angles, so I know that this is 50 degrees, and I also know that this one is 130 degrees. So you should be able to get all the angle measures if you have one, because a straight line, if you have a straight line, you know that that is equal to 180. Okay, now an arc is a portion of a circle. A semicircle, we just talked about that. That makes an arc that is 1/2 of a circle. The minor arc is an arc that is less than a semicircle, and a major arc is an arc that is greater than a semicircle. And we can write them as like arc. Minor arc is less than a semicircle, so look at this circle here. A semicircle would go like from B to this point over here that doesn't exist. That would be half. So a minor arc that is noted here would be like A to B. So we could say arc AB. We can also, or we can say this. We can do the A and the B, capital letters, and put a little arc over it. A major arc, since it's greater than a semicircle, I could also use arc AB here because it is from A to B, but an easier way to do that would be to include C. So I could say this is arc ACB, kind of like angles. It goes from A to C to B. Or you can make this as capital letters ACB with the arc symbol over it. Now, we can measure arcs by using the measure of the central angle. This is in degrees. Okay, the measure of the arc is equal to the measure of the central angle. So AB, the arc AB is going to equal, this is a right angle, so this is 90 degrees. So the arc AB measures 90 degrees. And we can do the same with ACB. We can find ACB is going to be, remember there are 360 degrees in a circle. So it's 360 degrees minus the 90 we already used. 270 degrees then for arc ACB. Now, there are two ways to think about arcs. We can measure the arc, that's in degrees, or we can talk about the length of the arc, and that would be a fraction of the circumference. It's going to have a length measurement. So, this circle, we need to find the circumference. Remember that circumference equals pi times diameter. And for this example, let's just leave pi as pi. Now that may not be the case in all of the examples, but in this one, just so that you can get the idea, that's what we're going to do. So find the circumference. Our radius is 6, so our circumference, our diameter, would be 2 times 6. So our diameter is 12. So our circumference is going to equal 12 times pi, and it's inches. Now, if we wanted to find the arc measure, the length of AB, we would figure out what fraction of a circle it is. So it's 90 degrees. It's 90 out of 360, which is 1/4. So we need to divide this or multiply it by 1/4 or divide it by 4, and that will tell us that this is 3 pi inches long. Okay, so that's pretty much all there is to arc, central angles and arcs. I know we've done some of this in the past, so hopefully it'll come back to you really quickly. Just remember that if you're measuring an arc, it's degrees, and if you want the length of an arc, it is in the units, the inches or the feet or whatever length measurement they're using. So I'll leave you with that, and I will see you in class.